And Phil's ear is immortalized. Your left ear is in camera shot. It's not blocking anything, it's just.
That's okay, there'll be a lawsuit in coming years.
Yeah, suing a teacher, they make so much money.
Yeah. Work out really well, I'm sure.
However, if you would like me to edit that out, I could edit out the ear. Any questions?
Number 5.
I said what a master set.
Yeah, like I get like general concept of it, but like it doesn't work with my brain very well for some reason.
All right, the first part is a math question. There are 2 answers to A. I just need one of them. Although I did say belt plate. All right, so we're dealing with a very large, almost infinite thin plate. I know that in that situation, that if I have a very thin plate, side view, the electric field is perpendicular to it. So in this particular case, I have an electric field that is going into negative I, positive, so my electric field is going in that direction. So I just need to find, I have an origin here. And 5 centimeters from the z-axis, so that's x-axis and y-axis, z-axis coming out, assuming a right-handed coordinate system.
Why do we always do X and Y vertical? Because like when I start taking calculus 3 now, they always put the z-axis up and then the Y and X like on the side.
This seems simpler to me.
Yeah. Oh, it does to me too, but like
They put the X like this.
they put the X coming out and the Y to the right and then the Z up and down.
Huh.
Yeah, like that.
It's basically that, but instead of, it's like a 3D figure of it. It's still X and Y are on the 2D plane. And
I mean,
just come
there are
out.
times in which this is convenient, and there's times in which that's convenient.
Yeah. It's just annoying that it can't be like the same.
When do the math people going to conform? All right. So, uniform surface charge density, so the classic standard, 5 centimeters from the z-axis. So basically, the z-axis is right there at the origin coming out, and so it's going to be 5 centimeters from that. So it's one of those 2. Just, I don't care which one you pick. It's just going to be one of them. Since z can be any number, because it's infinite plane here, all I need is, in essence, the formula of that line. Well, it's perpendicular to this, to the electric field. Therefore, well, if I know the slope of this, and there's enough information there, because it was, what, 10 by 25? The slope of this is the negative inverse. And so now it's just a matter of figuring out the other part of it, the intercept. So I just need one point that'll work. Let's see. So that angle there would be that angle there. Yeah, I'll do that. That angle would be that angle.
Is this intersecting the X axis?
Is,
The line that's coming out is the intersecting the X axis?
yeah, it intersects right, the X and Y axis.
And if it was like above it or something.
I'm not quite sure of that.
Like I said, it doesn't work that well in my brain trying to visualize it for some reason.
So X, Y, Z.
Yes.
So if, well, I also could figure out that angle from the slope. Seems like the first time I did this, I went through a lot of hoops, but there's a simpler way of doing it, I'm trying to get to the simpler way before I.
You could just use the equation of a plane, right?
Yeah, but you need to know a point it's going to.
The point would be the one it gives you, I mean, the vector, right?
Well, that's not the plane though, that's perpendicular to the plane.
But can it describe the plane then, since we have the perpendicular vector?
No, it would describe the area vector, but not,
I mean, negative 25, 10, 0.
because all that would do, if we use that to describe it, that means that it could be anywhere. But I specified that it's 5 centimeters, that this distance from here to here is 5 centimeters. Or here to here, whichever one you want to use. So it would, so what that vector would do, it would identify the orientation of it, just not the location of it. So the inverse, so I've got y is equal to negative 25 dense, or negative 2.5 x plus b. I just need to figure out what b is, I need to figure out what that point is. I know. Apparently 3 hours of sleep is not really good for thinking.
Well, I'm glad I'm not the only one who finds it hard to think about.
There's. I think this was a matter of just looking up, although you probably can, Wolfram has something for it.
There's something we were doing in Calc, well, the reason I said that, because there was something we were doing in Calc 3 recently, that was like, if you have the normal vector of a plane, you can find out the plane, and this,
Yeah, the difference is the exact location.
it doesn't have to be an exact location though, right, because it's an infinite plane.
No, but it is a certain distance from here.
But it's not the origin, right,
It's 5 centimeters from the origin.
I thought it's just 5 centimeters from the z-axis, not.
Yeah, well, the z-axis goes through the origin right there.
Yeah. Okay, well then I know.
Alright, so.
Did you figure it out?
No, I
Okay.
don't think I did, no.
Let's,
Okay.
alright, so.
Oh, okay, cause it's like.
I know that if I have, electric field lines are all going in that basic direction, but I'm just gonna take the one that's going through the origin, because for convenience.
That's the same thing.
This, I know that if this electric field line going through the origin would also have to go through the point, 2510. Because it was negative 25, there we go. The electric field, given in the problem, negative 25 newtons per coulomb I hat plus 10 newtons per coulomb J hat. So if it's going through here, it has to be at the point 25 negative 10. The distance, this point is from the origin. So the distance, I'll call this point A. The distance A to the origin is the square root of 25 squared plus 10 squared, which is the square root of 725, whatever that is. And so we can make, so if that is centimeters, this would be centimeters. So this distance here, that distance would have to be 5 over square root of 725. That badly worded. This distance here is, well, different color probably help me. So that distance there is DAO, and this distance here we'll call DPO, E for plane. So that ratio there would be 5 centimeters to the square root of 725. Ratio of that to that. But that also should be equal to the ratio of, well, the x coordinate and the y coordinate. So that's going to be the x. So the distance from here to here would be words not coming to me right now. So the ratio from here to here would be the same ratio as from here to here. And I know the distance from here to here is 25. This would be x of d. I do the same thing for the other one. Square root of 725 would be y to p over, I guess, negative 10. I can solve for xp and yp. Once I have those, I can now plug into this equation and figure out what b is. And that would be the equation of the plane.
And then the surface charge density.
I know that the electric field, the magnitude of the electric field coming off of an infinite sheet of uniform charge density is the surface charge density divided by 2 epsilons of naught. I gave you a vector form of it, finding the magnitude, that right there, or 725, square root of 725. Epsilon's a not so constant, solve for sigma.
Oh, okay. Sigma is the charge density.
Surface charge density.
Surface charge.
I think sigma is what your textbook uses. I think it was the previous textbook that used.
Do we ever use that?
Pardon?
Do we ever use that? The like it was.
No, it's in the flash, but that must have been what the previous textbook used. I don't know why. I mean, the tradition is you think of what are you representing, what's the letter, what's the sort of Greek equivalent. Surface starts with an S. Just use sigma. Questions? Other questions? Thank you. There is another way of doing that, because I feel pretty sure that is not the way I did it in my solutions.
It mostly makes sense, I think.
In essence, I have two triangles here that are similar. I've got this one and then the larger one. And so the ratio of sides, this to this, should be equal to that, ratio of that to that, or this to this.
Is the plane plane you're looking at perpendicular to that triangle?
The plane would be the one going through that point, but I was just trying to identify a point in the,
To get
a point in the plane, just so I can figure out the intersection. And presumably somebody's come up with a formula that would simplify it if you know what the formula is, but. All right, let's transition to chapter 26.